In this lecture, I'm going to give a quick reminder about how percentage calculations work. Here's the problem that we're going to do. A shoe store is holding a clearance sale. I find a pair of shoes I like. The original price is $60. They are 20% off because of the clearance sale. I also have a coupon for an extra 10% off one sale item. The sales tax is 8.5%, or at least it was at the time that I wrote this particular problem. What is the final bill for these shoes? Okay. What I'd like for you to do is pause the video and give this problem a try. You'll need your calculator, and then resume once you've had a chance to figure it out. Okay, let's give this problem a try. Let me do this in black. Okay, shoe store problem. The original price of the shoes is $60. Now, the way these stacked coupons work, or stacked discounts, usually the cash register will first apply whatever store-wide discounts are in effect. So let's deal with the clearance sale first. That's for 20% off. Okay. Well, the convention is that 20% off of 60 is, well, you take the 60 and subtract 20% of the 60. So first thing to remember is that a percent indicates a fraction with a denominator of 100. So 20% really means 20 over 100. You can convert the 20 from percent notation to ordinary decimal notation by dividing the 20 by 100. And an easy way to do that is to hop the decimal point 2 notches to the left. The second thing to know is that the of indicates multiplication. So just like half of a quantity means you're going to multiply that quantity by 1/2, 20% of a quantity means that you're going to multiply it by a fraction 0.20. So what we are supposed to do now is, well, 20% of 60 is 0.20 times 60. And you can calculate that, it's 12. So then 20% off 60 is, well, 60 minus the 12, which you can calculate is 48. The next phase of the calculation is the coupon. The coupon is for 10% off, and the convention for these stacked discounts is that you apply each to the result of the previous one. So what I need is 10% off 48, and that is 48 minus 10% of 48. Again, the 48 comes from the previous step. As before, I'm going to do this by subtraction. Let me do this. So 10% of 48 is, convert the 10% to 0.10 and multiply by 48 to get $4.80. Then 10% off 48 is the 48 minus $4.80, which is $43.20. And in case you're watching this carefully, you'll see there's a significant difference between 10% of and 10% off. Watch those F's. Now, just so that it's clear, there's a calculation that we are not interested in, which would be to take the 20% plus the 10% coupon and get 30, and then do 30% of 60 to get 18, and then do 60 minus 18 to get 42. That would be the result of adding the rates of the two discounts together and then using that for one of these percent calculations. But as far as I know, no store ever does stacked coupons like that. And a quick way to see why is that if something was 50% off and someone walked in with a coupon for 50% off, the store does not intend for the item to be free. They intend for you to start with the initial price. The first discount takes it down to half. The second discount will then take it down to half of that, which is a quarter of the original price. Okay, so just keep that in mind, and we're going to delete this from our work. All right, we've done both of the coupons. Now we need to do the sales tax. So there's a tax rate, and the tax rate is 8.5%. As a point of confusion, this is yet another use of the word rate. In this context, it doesn't indicate a derivative. It indicates instead the percentage that we're going to add to get the tax, the value including the tax. Okay, so 8.5% of, and I'll use the 4320 from the result of the previous calculation. Now this is a part where it's easy to trip. To convert 8.5% to a decimal, you hop the decimal point 2 notches to the left, and you have to stick in an extra 0. So just because this is an easy mistake to make, 0.85 is 85%. 0.085 is 8.5%, and just so that you see this 0.0085, that would be 0.85%. Be sure that you're putting the decimal point in the right place, otherwise you're going to get crazy numbers. Oops. All right, come on. Seriously? Oh, there are days it does not pay to get out of bed. Okay, 8.5%. I need to multiply 0.085 by 4320. The result of this is 3.672. This is a tax, so it will be added onto the price 4320, which is 46.872. Usually prices like this are going to be rounded to the nearest cent. So round to nearest cent. And the final price, will be $46.87. Having done this problem, I'm going to go back and show you a different way to organize the calculation. First, we did the 20% off from the clearance. And the calculation that we did was 60 minus 0.2 times 60. Well, I'm going to go over here and factor out the 60. I'll get a 1 from that term. I'll get subtraction from the subtraction, and then I'll get a 0.2, and I can write it as 0.20 just to remind you that that's the 20%. The next thing we did was 10% off the 48. So we did 48 minus 0.1 times 48. Again, I'm going to factor out the 48. I need a 1 for that term, then the subtraction, and then 0.10, just to remind you that that's the 10% coupon. And the 48 is the result of the first stage. Then we did the tax, and the calculation we did there was 43.20. This time it was added because it was tax. 0.085 times $43.20. Again, I will factor out the $43.20 this time. I need a 1 for there. I need addition, and then I need 0.085. And again, where did the 43.20 come? That was from the previous step in the calculation. So if I now look at what we've done, we started with 60, multiplied by 1 minus 0.20 to take 20% off. That was the 48. We then multiplied that by 1 minus 0.10. That was the result of the coupon. And then we multiplied by 1 plus 0.085 to get the tax. So here we go. Clearance, coupon, and tax. And in each case, what you're doing is multiplying by either 1 minus a discount rate, or over here 1 plus a tax rate. Since multiplication is commutative, you can do this calculation in several different orders. You could do the tax first, and then the coupon, and then the clearance. You could do the coupon first, then the tax, then the clearance. Any order that you come up with is going to give you the same final result. That's because each step is effectively multiplying something by 1 plus a rate or 1 minus a rate. And I'm pointing that out because that will come into play when we start talking about compound interest. So there's the shoe store problem.